Hey everybody, it's Miss Saltstein. Camera's not working for some reason, but that's okay. This lesson is on adding numbers in scientific notation, and believe it or not, this is something you already do, okay? If somebody told you you were going to get 5 million and then you were going to get another 3 million, you would say, oh, okay, that means I'm going to have 8 million. All right. Um, You could, if you wanted to, write it like this. 5 times 10 to the 6th power. Okay, 10 to the 6th power is a million. And then you could write 3 times 10 to the 6th power. Um, they're usually going to write these in parentheses because of the order of operations. We want to make sure we're multiplying before we're adding. But you would do this the same way. You would notice that the power of 10, that's the million, is the same here. Okay, you have a match in the unit of measure, and that is a million. And you would simply add the 5 plus 3 and then keep it times 10 to the 6th because it's still millions. All right. This is how we're going to add the numbers in scientific notation. So same thing you've been doing, but we're going to be writing it in scientific notation. And we're going to be using that Lars adjustment that we used in the last video. And don't worry if you didn't watch the last video, I will explain it again. But it's right here on this chart. Basically, it says if you want to move the decimal and a number's in scientific notation, fine. Move the decimal to the left, you're going to add 1 to the exponent. Move it to the right, you're going to subtract 1 from the exponent. And that keeps the number at the same value. All right, so if you look at this first problem, 10 to the 4th is 10,000, okay? So we're adding two numbers that have the same place value, the 10,000s, okay? So 5.75 of those 10,000s plus 3.81 of those 10,000s. Guess what? Since they're both the same thing, they're 10,000s, we can just add the numbers. I'm going to just rock a little column addition here because it'll take me just as long to grab the calculator, but you can use the calculator if you want, no big deal. 5, 6, 7, 8, 9. All right, so now if I add these together, I'm adding the number part and I'm getting 9.56. The power is going to stay the same, 10 to the 4th power. Okay? So that's a nice one because the powers were the same. But what if they're not? What if the exponent is different, like this next one? Well, guess what? You can still do the problem. Here are the steps here, okay? And I've included this chart. It's attached to the lesson in the lesson notes. So you can download it and have it for yourself. This says convert to the highest exponent. Use Lars to make the adjustment so you're still in scientific notation. Remember, you're only allowed to have one digit to the left at the decimal point. Okay, and it can't be a 0. Then you can do the same thing we just did. So this one, I have my largest exponent is 10 to the 5th power. That means I want to add 2 to my exponent of 3 to get it to be to the 5th power. Okay, this first number I'm going to leave the same. Okay, because I added 2 to the exponent, okay, remember Lars, L-A-R-S. I added, okay, plus 2. That means I'm going to move to the left 2 units to keep that in balance. Because basically, I just, with this 4.93, I just made the number a whole lot bigger than it was. Okay? If I make the exponent, 10 to the 3rd is 1,000. If I make it 10 to the 5th, that's 100,000. I can't just make the number bigger. Okay, so the way I keep it balanced and equal to the same thing it always was is by moving that decimal. And I'm going to move this. I don't have enough room here, so I'm going to rewrite that. So decimal moves 2 places to the left. I get 0.00493 times 10 to the 5th power. Okay. Now, if you look, they're both 10 to the 5th power. You've got to have a match in your power of 10. Okay, these are both 100,000s. 6.81 100,000, 0.00493 100,000. Okay, so it's just like when I was adding 5 million and 3 million. I'm going to add the number part. 6.81 plus 0.00493. Let me annex some zeros here just for, placeholders. I'm adding straight down, lining up the decimal. You can totally do this part in a calculator, no big deal. Okay. This is kind of like a 5th grade math kind of thing going on here. So now I have, oh shoot, I just realized they wanted this 10 to the 3rd power. Let's ignore that for right now. And I'll show you that on another problem. 6.81493 times 10 to the 5th power. Okay. So again, get the powers of 10 to have the same unit. Then you can just add the number part and leave the power of 10 the same. Let's look at one with negative exponents. Okay. This one is going to stretch you a little bit, stretch your brain a little. Okay. I'm actually going to rewrite it over here so I have a little more room. 3.82 times 10 to the negative 4th power plus 1.95 times 10 to the negative 3rd power. Okay, and if you look here, they want me to get the exponent to be -3. So guess what I'm going to do here? Okay, and this is where it's going to stretch your brain a little bit. I'm going to add 1 to the -4 because -4 plus 1 is -3. Okay, if you don't believe me, you've got to grab that calculator. Okay, this is 6th grade math. So, sometimes that kind of math didn't stick with us that well because it was pretty recently. Okay, -4 plus 1 is -3. All right, because I added to the exponent Lars, so I added 1 here. That means I'm going to need to move the decimal to the left one time. 1 power of 10. There we go. So now I get 0.382 times 10 to the negative 3rd power. Okay, the other guy is going to stay the same. I didn't need to do anything with him because he already had the negative 3rd power. I just want to match. Okay, I want the power of 10 to be the same. Okay, 10 to the negative 3rd power is 1,000th. Okay, the thousandths place. Tenths, hundredths, thousandths. So these are both thousandths now. Okay, 0.382 thousandths plus 1.95 thousandths. So now that they're the same thing, I can just add the number parts. You can do this on a calculator. I'm going to do it like this. It will give you time to think about what's going on, and it will make things a little more transparent, but go right ahead and use the calculator. 9, 10, 11, 13. All right. So the number part of my answer is going to be 2.332 times 10 to the negative 3rd power. Okay, and guys, I want to show you something before we're done. All right, this is question 3 on page 5. I'm gonna, oh, there, see, here it is. They're gonna, actually, I don't have to enter the power of 10, but I'm just gonna check my work. So 2.332. Let's see if I got it right. 2.332. I'm gonna click away to make that go away. And then I'm gonna check answer. Yes! Got it right. All right, guys. That's that.